Okay, saw some major problems on the derivative worksheets. Just showed the answers here. You better be very clear on your work on finding these derivatives, and I'll talk about a couple of them here. Okay, so I'm not going to show this one, but just have your algebra clear. I just kind of pulled the key answer. Same thing with this one. This one kind of show a few steps of work because this is where the disasters come into play. First of all, don't be a lazy bum. Limit as h approaches 0 of f of x plus h minus f of x all over h. Then the purple shows what you have to multiply both top and bottom by to get rid of these little fractions. When you distribute this cancels. Okay, my pen's not working. That's fun. Okay, let's see if it works now. Hooray! All right, and then you're left with 8x, and then when you distribute to this, the x's cancel, and you're left with minus 8 parentheses x plus h. When you distribute, again, limit still here, because you haven't evaluated, and then cancel oh boy, the 8x's cancel. Then you're left with this. Then, to find the derivative at a specific point, then you plug in this -1. Now, what this is the slope of the tangent line at -1 comma, whatever that point is. That's an awfully steep negative slope line there, so just kind of showed that on my key just to explain that. So better make sense out of that. Your work better look pristine. I'm not going to keep describing number 5. That's exactly what happens in number 5 as well. Number 6, I didn't go all the way, but just like I discussed in class with those that were here. All right, you got an x cubed. So the limit of f of x plus h minus f of x all over h as h approaches 0. Describe what that is. As far as where we get that formula from, I'd use Pascal's triangle for cubing this. So it's going to run out of room quick. I'll just write this real fast, and then you should be fine. To cube x plus h cubed, you get 1 x cubed, plus 3 x squared h. The powers on x go down, the powers on h go up. Remember, this is h raised to the 0 if you wanted to write it. And this is the binomial theorem. Plus 3xh squared. Going to run out of room real fast. We're going to go down there. This is going to be crazy. Plus 1h cubed. And then plus 5x. Don't ever do this on the test, by the way. I'll mark that wrong so quick. Your head will be spinning. Plus 5h. And then minus x cubed minus 5x all over h. And a whole bunch of good stuff happens. Basically, everything without an h. What happens, everybody? Cancels. Then the next step is we'll pull an h out. Limit as h approaches 0. Pull out that h already. And you have 3x squared plus 3xh plus h squared plus 5 all over h. Then when this cancels, you can plug in 0 for h, and you end up getting 3x squared plus 5. Then you plug in 1. Okay, enough. Slope of a tangent line, you should understand that when you get the derivative of this through that complicated math, and then plug in 7 into the derivative formula, that just gets you -14. Where this point comes from is, this is 7 comma 56 exists on this graph. And remember, this is 7 comma 56. That's where the tangent line's crossing. So the tangent line also has that point on it. So that's why that is the equation of a tangent line. All right, here we go. Number 8. For those that did it, watch. For those that didn't, I don't know. Take a look. So, same directions. Find the equation of the t line, the tangent line, is what at x equals 9. So I guess what we could do right now, what is the square root of 9? 3. 3 times -5. So this point is on this graph. The Tangent line. You know what? I'm actually going to go ahead and graph it first before I do my limit stuff. And then I'm going to erase it. Okay. By the way, I plug in 0, I get 0. I plug in 1, what do I get? -5. I plug in 9. What do I get? I think that's 15, what I counted. All right, so what I'm doing is just trying to get you a picture. All right, here's the graph, and that's an upside down square root function, classic shape. What you're finding is the equation of the tangent line that shares that point. So what we have right now is y plus 15 equals mx minus 9. You need to understand that. And what we're trying to find then is the slope of the tangent line. The slope of the tangent line comes from the derivative formula, which I derived, how a secant line turns into a tangent line. It's only when h, the distance between the x's, gets closer to 0. You can look at that again. It's not about understanding right now. I guess it's about doing. So the limit of f of x plus h minus f of x all over h. So this is a slope formula, all right, of the secant line, but then as h approaches 0, then it turns into a tangent line. All right, I'm, again, over-explaining. Trying to jump back Friday, I guess. What you want to do is rationalize the numerator. Oh, by the way, this is plus. So, all right, the conjugate, I'm going to write negative. And the conjugate of this is minus 5 root x. This is what you want to multiply top and bottom. Came out of left field. I think I had to tell you this Monday. Maybe. Do we do derivatives Friday? First time? Or Thursday? I think it was Thursday, then Friday I came back and showed roots. And I put it on the video. If you weren't here Friday, you could watch it. I think I did. Almost positive. All right, and then it's not a big deal because this is just -5 times 5, which is, and by the way, its limit as h approaches 0 until you plug in 0. I'll take a point off every time you don't write this, because I mean, plus you're lazy. Good morning. And then freedom, x plus h. So that's all the first is. Outer and inner cancel because they're conjugates. So all I have to do is the last. 5 times -5 is -25. And then luckily root x times root x is x. Luckily you don't have a chance for a distribution error, which often happens in these. It really isn't that hard. Just got to get through that, and then it's pretty much a standard deal. All right. So you distribute. I'm going to go ahead and do that and then do 2 canceling in the next one, just so I don't overslopify the question. 25x plus 25h minus 25x. I know. Made a mistake. Okay. H, -5, root x plus h, minus 5, root x. Now I'm going to be lazy and cancel these h's, and then this is the time where the limit goes away. So I have 25 over -5. I writ x plus 0 minus 5 root x. Now what I choose to do is call this f prime of x. By the way, what's -5 root x minus 5 root x? What's 25 over -10? -5 over 2 root x's. There's my slope formula. So how I describe this to begin with, y plus 15 times m x minus 1. Oh, let's just cowboy that. You know how much we love that. Yee! Wait for it. Ah! Okay, now, remember this is the slope at x equals 9. So that's what I can do now. I can plug in 9 into the derivative formula, the slope of tangent line formula, and get what's square root of 9? 3 times 2. So -5/6. So it's y plus 15 equals -5/6 x minus 9. And then if we look at this picture right here, Okay, it's at least a negative slope, right? You know, again, this is just a sketch. So drop 5, run 6, kind of close, I guess. Probably made it look a little bit less steep than it really is, but that's fine. And then if we had to be mean and distribute, why did he do that? Because this is 45 sixths, which is 15 halves. Subtract 30 halves, and then this is what you get. So there's the equation of the tangent line of this little picture.